Hello Year 6 and welcome to your third biology lesson in your Year 6 to 7 Science Bridget unit. Right, the first thing I'd like to do is look at these 5 pictures of the animals and decide which of these animals live in a hot environment and which of these animals live in a cold environment. And then when you've done this, start thinking about what do the animals that live in the hot environment have in common and what do the animals that live in a cold environment have in common. So did you say that the Arctic fox, the polar bear and the whale live in a cold environment and the camel and elephant live in a hot environment? So why would you never find a polar bear living in the desert? This is because organisms will only live and reproduce where conditions are suitable. So you will never see a polar bear in the desert, just like you would never see a camel in the North Pole. This is because they have not adapted to live there. They have adapted to live where they live. So when we're talking about an animal adapting to its environment or an organism adapting to environment, we mean the process of change by which the organism or species becomes better suited to its environment. So basically, when we're talking about adaptations, we mean that the organism has developed special features or behaviours that allow it to be successful in their environment. Adaptation. Special features or behaviours that allow an organism or helps an organism to survive. So today's lesson we are looking at adaptation. So first of all, I want you to be able to define the term adaptation. I want you to be able to identify the adaptations of animals who live in a hot climate and animals who live in a cold climate, and also be able to identify variables in an experiment investigating the effect of a fur coat on heat loss. So now that we know that an adaptation is just a special feature that allows an organism to survive in an environment, we're going to look at different adaptations and see if we can identify those that would allow an organism to be more successful in a hot climate and those that would allow an organism to be more successful in a cold climate. But before we do that, we're going to look at some terms that you might not have come across before. And these are surface area to volume ratio. So you'll notice here we've got a large surface area to volume ratio, and it says as well small surface area to volume ratio. So what do the terms surface area and volume mean? So during your time at primary school, you'll have learnt that area is defined as the amount of space taken by a two-dimensional shape or the surface of a shape. Okay, and you'll have learnt to calculate area by doing length times by the width. We're going to think of area as just the space that is exposed to the outside. Okay? Now, volume, you'll have learned that volume is just a measure of the space inside a three-dimensional shape. So it is just the amount of space that a substance or an object occupies. And you've learnt to calculate volume by doing length times width times height. Now, if you can't remember those calculations, don't worry about it. We will pick that back up when you come to see us in September. But if we look at the shape on the left-hand side, so the large cuboid, you will see that at the moment, the area or the surface area is just the parts of that cuboid that are exposed to the outside shape, to the outside space, okay, to the outside air, if you like. Now, you'll also notice that that cuboid is made up of 4 smaller cubes. And if we were to split that up into the 4 smaller cubes, you will see that all of a sudden the hidden surfaces that were hidden because of the fact that these cubes were next to each other are now exposed, meaning that the surface area has increased. So remember, surface area is just the total of all the area of each of the sides of the objects. So it's how much of a shape is exposed to the outside. Now, you'll notice as well that the volume, so the amount of space that these objects take up, stays the same. So we would say on the left, there is a smaller surface area to volume ratio, whereas on the right, when we split those cubes into the smaller 4 cubes, there is a larger surface area to volume ratio. So if we were to put this into context, I want you to imagine that you're really, really hungry and you're having a jacket potato for dinner. Now, the problem is that this potato is extremely hot. Which of these potatoes do you think you will be able to eat first? The potato that has been cut up, which is shown on the right, or the potato that hasn't been cut up, shown on the left? So, well done if you identified the potato on the right as being the one that would cool down faster. Now, which one has got a larger surface area? Which one has got more of the potato exposed to the outside? Well done again if you identified this as being the potato that has been cut up. So as both potatoes were the same size, we would say that the one on the right has got a larger surface area to volume ratio. So just to recap, both potatoes are the same size, which means they both have the same volume. However, the potato that is cut up has more surface exposed to the air, so we say it has a large surface area to volume ratio. The surface area to volume ratio of an object is just a relationship between these two measurements. It is a ratio of surface area to volume, and it shows a comparison between the size of the outside of an object and the amount inside. So now that we understand the term small surface area, so let's see if we've got these adaptations right. Any adaptation that turns red shows an adaptation of an organism who lives in a hot country, and any adaptation that turns blue shows the adaptation of an organism that lives in a cold country. So let's look at these again. So a camel, it has a large surface area to volume ratio, which allows it to lose heat quickly. So think about on a hot day when you get into bed and it's absolutely boiling, do you snuggle up in a little ball or do you lie like a star? I'm guessing you lie like a star because it allows you to keep cool. It allows heat to be lost from your body at a faster rate, allowing you to remain cool. Camels can also drink lots of water at one time, and a camel can actually drink up to 200 litres of water in 3 minutes. Now that is a lot of water in a very short space of time. Now camels have also lose very little water throughout the day. So obviously we lose water through urine, we use water through sweat. So a camel produces little urine and it produces very little sweat, enabling it to conserve any water that it has. Finally, all fat in a camel is stored in the hump, so it's not stored in a layer under the skin like in a lot of organisms. It's stored in the humps on the back of the camel. They don't store water. Water can be converted into fat and it is stored in the humps. That means that it's reducing the amount of insulation around the camel, allowing it to lose heat effectively. And something that isn't written on there, but camels have also got a sandy colour which provides them camouflage in the desert. So well done if you got those features, those adaptations that enable the camel to survive in hot deserts correct. Right, next we're going to be looking at the polar bear. So a polar bear has a small surface area to volume ratio. So this just means that the shape of the polar bear is compact, even though it's still very large. This keeps the surface area to a minimum to reduce loss of body heat. So think about when you're cold and you get into bed and it's freezing cold, do you lie like the star or do you snuggle up into a ball because it keeps you warmer? So obviously you're reducing your surface area and you're reducing the amount of heat loss from your body. Now, polar bears also have a thick coat, and they actually have 2 layers of hair, which obviously provides a lot of insulation. The fur is also greasy. It's not nice and fluffy, it's greasy, so it doesn't hold water, because remember that polar bear is in and out of water. Now, unlike a camel, polar bears have a layer of blubber underneath their skin, again reducing heat loss because it's insulation. They are white so that they are camouflaged, and they also has big feet to spread its weight on snow and ice so it doesn't sink through. And what it doesn't show on there is that polar bears are also extremely good swimmers and runners to catch prey. So what we're going to do now is we're going to carry out an experiment to investigate if one of these adaptations, one of these features actually do help prevent heat loss, does help keep the polar bear warm. So our aim of our experiment is to investigate the effect of a fur coat on heat loss. So you're going to need the following for this. You're going to need some water, you're going to need 2 glasses, preferably the same size and shape. You're going to need a timer or a stopwatch, or the timer on your phone will work. You'll need a measuring jug, a woolly hat, and if you have, a thermometer, or 2 thermometers if you want one in each glass. Most importantly, you are going to need permission from an adult. So we're now going to carry out our experiment to investigate the effect of a fur coat on heat loss. Now, before you do this experiment, please make sure you have asked permission from an adult. Can I also ask that you explain the experiment to an adult, because they might choose to supervise you when you're doing this. So to investigate the effect of a fur coat on heat loss, we are going to start with 2 glasses. Now, if you want to use mugs, that is fine, but all we are going to say is we're going to keep remembering that we're going to make this a valid test. And to make something valid, we need to control any variable or anything that could affect the heat loss from this glass. So what you'll make sure you're doing is you'll make sure that the mugs or the glasses are the same size, they're the same shape, they're the same thickness, and they're made of the same type of material, because all those things could affect the rate of heat loss from the glass. You're then going to place some water into each glass. Now, again, making this a valid investigation, you're going to use your measuring jug to make sure that you've used the same volume of water in each glass. You'll then use a thermometer to record the start temperature of the water. After this, you'll write the answer, the temperature, in your results table, and then you will place a nice woolly hat over one of the glasses, and you will leave both of them in the same place for 10 minutes. Now, again, it's important to make it valid that you leave both of them in the same environment, so the same room temperature, for the same amount of time. After 10 minutes, you'll remove that woolly hat and you will re-record the temperature of the water. So you'll record the temperature of the water at the end. Now, I understand that for some of you, you might not have access to a thermometer, and that's not a problem. You could still do a simpler version of this experiment. So you can do the same thing, but this time you will use your fingers to test the temperature of the water. So make sure that you're not using boiling water, but you'll use the temperature of you'll use your fingers to record that the temperature the water is hot and roughly the same at the beginning. And then after, I would say 15 minutes, to make sure it has had time to cool and you can test it, put both fingers in the water at the same time and see if there's a difference in temperature. And you'll then be describing one as maybe hot, one as warm, one as lukewarm, or hot or hotter, or warm or warmer, but you'll be able to identify if there's a difference in the temperature of that water. Now then, year 6, what we now need to do is draw a results table to collect our results in. So with most results tables, in the first column, we always include the independent variables. So in this case, it's do they have a fur coat or no coat? In the next column, we're writing temperature of the water at the start. In the third column, temperature of the water after 10 minutes. And in the fourth column, temperature change. And notice I've included units for all of them, degrees Celsius. Now, the temperature change is really important because we know that where we see the biggest temperature change, the biggest temperature drop, will tell us where the greatest amount of heat loss has come from. So where there is a greater temperature change, it means more heat has been lost. Now, I'm aware that some of you might not have access to results table. Again, it's got the same independent variable, but you've then got the temperature of the water at the start. In this case, I just want you to test using your fingers if they're about the same temperature. Remember, we're not using boiling water. And if they're the same temperature, you can just write hot, but you've tested that they are as close to the same as possible. Then after 15 minutes, you're going to do the finger test again. Put your fingers in each of the glasses and is there a difference? Is one of them warmer than the other? And you'll have to use words like warmer, colder. You could still have hot. You might even have cold, which will help you answer this question when you're describing the temperature of the water after 15 minutes. So our aim for this experiment is to investigate the effect of a fur coat on heat loss. Now, last time when we did an experiment in chemistry, we looked at these keywords, independent variable, dependent variable and control variables for when we are planning an investigation. Now, I would like you on a piece of paper, see if you can remember what we mean by independent variable, dependent variable and control variables. So if you pause this PowerPoint now and have a go at answering these questions, telling me what we mean by independent, dependent and control, and then we'll go through it. So did you say that the independent variable is what you are changing in the experiment? Did we say that the dependent variable is what we measure in the experiment? But remember, when we're talking about what we're measuring, you need to explain how you will measure it. So what it is that you're going to actually do in the experiment to measure heat loss. And that control variables are the variables that we keep the same. Now, also remember that we don't use the term fair test at Key Stage 3. We use the term valid. So I want you to think about, for this experiment, what will your independent variable be? What will your dependent variable be? And what will your control variables be? And I would also like you to tell me how you will make this a valid test. So, how did you do? Did you identify the independent variable, so what we're changing as whether or not the glass of water or the organism has a thick coat or no coat? Did you identify the dependent variable as the temperature change? And then did you identify that to make the investigation valid, you would control the following: that you would keep the volume of water the same, the shape and size of the glasses or the bowls the same, you would keep the room temperature the same, you would leave it to cool for the same amount of time, and you would also keep the temperature of water at the start the same. Well done if you got all them right. So you now need to carry out your experiment to investigate the effect of a fur coat out in your experiment. And so did you find out that a fur coat reduces heat loss? And remember, I asked you to tell me how you know this. And the easiest way to do this is to refer to your results. So something like the water without a fur coat decreased by, and then stating how your answer, degrees Celsius, whereas the one with a fur coat only decreased by, and stating that decrease. So well done Year 6 in completing your third and final biology lesson. So you can now define the term adaptation. You can identify adaptations of animals who live in a hot climate and animals who live in a cold climate. And you can also identify variables in an experiment investigating the effect of a fur coat on heat loss. I hope you've enjoyed these science